Okay, so this is part 3 of conditional operators. We should be able to finish it up in this video. So I showed you how to count from 0 to 8 in binary. So let's look at some of the bitwise operators, and they are always performed on binary numbers. So let's look at the first one, and. So in and, the symbol is 2 ampersands, and my ampersands are kind of pitiful. All right, so inputs are called operands. The operator is the and itself. All right, so if any of the inputs or operands are 0, the output of the and function is going to be 0. The only way you get an output of a 1 is if both inputs are 1. So let's look at an example. We have 2 binary numbers, and we are going to do a bitwise AND. So 1 ANDed with 0 is 0. 0 ANDed with 1, 0. 1 ANDed with 1, 1. 0 ANDed with 0, 0. 1 ANDed with 1, 1. 0 ANDed with 1, 0. 1 ANDed with 0, 0. 0 ANDed with 1, 0. 0 ANDed with 1, 0. Okay, so that's your new value of your AND operation. Now let's look at OR. So OR is basically like a binary addition, and you use the double pipes as the symbol for an OR operator. So how does the OR function work? Well, if you have 2 inputs and any of them are 1, your output is a 1 if you OR the 2 together. The only way you get a 0 is if both operands are 0, then you get a 0. So let's look at an example. 2 binary numbers, let's OR them. 1 ORed with 1 is 1. 0 ORed with 0 is 0. 1 ORed with 1 is 1. 0 ORed with 1, 1. 0 ORed with 1, 1. 1 ORed with 0, 1. 0 ORed with 1, 1. 0 ORed with 1, 1. 0 ORed with 1, 1. So there is your new value after ORing the 2 binary numbers. Our next operation is not or complement. And he uses tilde symbol to indicate a not operation. Basically, the way it works is that you have your operand, and if it is complemented, then it becomes the opposite value of what it was before. So if it was a 0, it becomes a 1. If it was a 1, it becomes a 0. So let's complement binary number that we have here. 1 complemented is 0. Complement of 1 is 0. The complement of 1 is 0. Complement of 0 is 1. Complement of 0 is 1. Complement of 1 is 0. Complement of 1 is 0. Complement of 1 is 0. So there is our new value. All righty, let's see here. So now we are going to talk about the shift operator. So in C, you're able to shift right and you're able to shift left. So how does it work? So if you shift right, what happens is that you're shifting your number this way. So what you're doing is adding zeros all the way over to the left-hand side of the number. You're adding in zeros in order to shift the rest of the number forward, okay? That's a right shift. A left shift is just the opposite. You're adding in zeros this way to shift this number to the left, okay? So let's look at a little example. We're going to start out with x equals to 3. So this binary number is 3. The leading zeros don't mean anything. They don't have any value, just like in a decimal number system. So 1, 1 is the binary 3. All right. So we want to shift this number 1 to the left. So we're going this way. all right, to the left. So we want to shift it by 1, so we add 1 0 here, and then we start shifting the values of the number. So this 1 goes here, this 1 goes here, this 0 goes here, 0, 0, 0, 0. Okay, so we got 1, 2, 3, 4, 5, 6, 7, 8. All right, so our new number, kind of messy, let me write it again, 0, 0, 0, 0, 0, 1, 1, 0. So that value of that binary number is 6. So what you'll find is if you shift the number to the left by 1, you multiply it by 2 actually. And so this is what is used in your arithmetic logic units in your CPU in order to do multiplication and division, because what you'll see is if you shift to the right, that becomes division. All right, so let's take this number and let's shift it to the left 3 times. All right, so we're going to put the number here. All right, so we're shifting to the left, so by 3, so we need to add 3 zeros. All right, and then we start shifting. So this is a 0 here, 1, 1, 0, 0. All right, so that's our new number. And this number is 48. That's the value of that number. All right, now let's shift to the right. We shifted to the left, let's shift to the right. So let's bring our number down. All right. We're shifting to the right this time. So we're going to add in a 0, and then we're going to start shifting. 0, 0, 1, 1, 0, 0, 0. And that number just falls off. Okay, so now we have a new number, and the value of this number is 24, because if you shift to the right, you divide by 2. All right, so this is 24. All right, and now let's shift the same number to the right by 3. All right, we're shifting to the right, so we're adding zeros. We're adding 3 zeros. 1, 2, 3, and now let's start shifting. So that 0 goes there, that 0 goes there, that 0 goes there, that 1 goes there, and that 1 goes there, and these 3 zeros just fall off. And guess what? We're back to the value of 3, which makes sense because we shifted to the left a total of 4, and we shifted back to the right a total of 4. So that should give us what we started with, and it does. All right, now let's talk about the ternary operator. What is a ternary operator? Well, if we break the word down, ter means 3, right? That prefix. So basically, this is an operator that deals with 3 expressions, right? And based on the evaluation of expression 1, it determines whether or not you will evaluate expression 2 or expression 3. So if expression 1 is evaluated and is true, then expression 2 will be evaluated and becomes the value of the expression. However, if expression 1 is evaluated and it's false, then expression 3 will be evaluated and becomes the value of the expression. So let's look at an example. Right here, we have assigned the value of 10 to x. All right, and we're trying to figure out what value we will assign to y. So the ternary operator is the question mark, because you're trying to figure out, am I going to take the first expression or am I going to take the second expression? Okay, so x greater than 9. Well, 10 is greater than 9. So that makes this expression true. If this expression is true, then we pick the second expression to be the value we assign to y. So 100 is assigned to y. All right, let's do another example. So once again, x is 10. This time we have the expression x less than 9 and the ternary operator. And we're gonna have to choose between these two expressions. So x is 10. 10 is not less than 9. So this expression is false. So since the first expression is false, we choose 200 as the value that we will assign to y. All right, let's put this in a program and run the program and make sure that we get the values that we just predicted that we should get. All right, so here's the program that I've written. Okay, we're going to declare our two variables as integers. We're going to assign the value of 10 to x, and we're going to use our ternary operator. Okay, and we're going to evaluate the first expression, x greater than 9, and see what our answer is. We're going to print the answer here. And the second thing we're going to do is evaluate our expression, x less than 9, and print what the value of y is. So let's run it. When we run it, this is what we get. We do get x is equal to 10, and the value of y is 100. Okay, 10 is greater than 9, so when we evaluate that, that's true. So the value of 100 should be assigned to y, and it is. Our second line, x equal 10, and the value of y is 200. Let's go down here. X less than y, well, x is 10, so that's false. So then we should choose 200 as the value that we will assign to y, and that is what we did. All right, so that's it on conditional operators. You know everything you need to know now. Later.